Hello. We're going to be talking now about solving some systems of equations, and we're going to do that graphically. Now, solving graphically is fairly straightforward. The point of this is going to be graphing lines, and to find that solution, you're just finding your point of intersection. If your lines are parallel, there's no solution. If your lines are literally the same line, it's called collinear, or you've got a dependent system. But let's anyway, let's go through a couple examples here. And the first one, I've got two different types of equations that we can do. I'm going to start with this one. Let's start with like 5x minus 2y is equal to 10. And for our second equation, we're going to do x minus y is equal to negative 1. Now, graphing lines it seems like it would be very difficult, but it's actually pretty straightforward. The thing that we're going to remember is you only technically need 2 points in order to graph a line. But three is good. But here's the thing. Depending on what the form of the line is, you're probably going to use some different strategies for graphing. But let's show you, if I've got something in this kind of standard format, this ax plus by equals c, this constant times x plus a constant times y is equal to a constant. This is a good time to graph using our intercepts. So with this, I will say let's take, actually I'm going to start over here. Let's figure out what happens if I plugged in 0 for x. We don't know what our y is just yet. So if I do 5 times 0 minus our 2y is equal to 10, well, 5 times 0 is just 0. So I've got negative 2y is equal to 10, and then I can just divide both sides by negative 2. So I've got y is equal to negative 5. That's pretty easy. So this has a y-intercept right there. Pretty similarly, I could figure out where my x-intercept is when I plug in a 0 for y. Plug in 0 for y, I've got 5x minus 2 times 0 is equal to 10. Again, anything times 0 is just 0, so this whole thing is just 0. So I've got 5x is equal to 10, and then I'll just divide both sides by 5. So I've got x is equal to 2. So just like that, we can graph our line. And the more accurate you can make that, the better. You probably saw me throwing a couple extra points on here. I just noted that I had a rise of 5 and a run of 2, so I just followed that pattern along. Rise of 5, run of 2, rise of 5, run of 2. I could figure out what my slope is. Well, this second one is just as easy to figure out what our points are. And I say easy, but I will say I have a lot of practice, so of course I make it look easy. But the process is going to be the same. X minus y is equal to negative 1. And once again, I'm going to put in, I'm going to say my x is equal to 0. And when I do that, well, that means this whole x right there is just going to be 0. So I'm just going to have negative y is equal to negative 1, and I'll divide both sides by negative 1. So I'll end up with y is equal to 1. Right there. Okay. What happens when I plug in a 0 for y? I'll have x minus, well, 0. Should have put a 0 there, but I didn't. X minus 0 is equal to negative 1. And sure enough, I'll just have x equals negative 1. Okay. So here, those are my 2 points. And again, I can see I've got a rise of 1 for a run of 1. So I'm going to just sort of extend this pattern out here for a little bit so to make my graphing easier. But just like that, we have our graph. And it looks like we've got this point of intersection here, and my x seems to be at 1, 2, 3, 4. So x is 4 and y is 5. So there's my solution, 4, 5. So like I said, when you're doing this, you're just going to be graphing your lines and finding that point of intersection. And kind of the downside of solving things graphically is that when you're solving things graphically, your solution is only going to be as accurate as your graphs. So it really helps to review how to graph lines, and that should really help with solving things graphically. Well, this one I used finding our intercepts to graph our lines. Let's use one of our other main techniques for graphing, and I'll have a different example here. And on this one, I'm going to do y is equal to 3x minus 4. And I'll also have y is equal to negative 2x plus 1. Now, when you're graphing lines that are similar to these, the nice thing is you literally have no calculations necessary. When you're graphing lines, especially in this y equals mx plus b format, remember, you only need two pieces of information. You need a starting point, which we can find as that y-intercept, and you need the slope. So for this y is equal to 3x minus 4, my starting point is going to be my y-intercept. And that's going to be 0, negative 4. And of course, my slope is 3, and I'm going to think of this as 3 over 1. So this is a rise of 3 for a run of 1. So I'm going to be starting out 1, 2, 3, 4 right here on my y-axis, and then it's going to go up 3 over 1. And I'm just going to repeat that. 1, 2, 3 over 1. I can do this as often as I want. Up 3 over 1. Up 3 over 1. Alrighty. So there's our first line. When you're graphing a line like this, literally, notice we didn't do any calculation. All we really have to do to graph a line that looks like this is count. Now, admittedly, I have something fairly simple where my slope here is integers. But if we have a fraction as the slope, that's also fairly straightforward. Still, here, my y-intercept is going to be 0, 1. So it's going to start right there. And my slope is negative 2. And again, I'll put that negative 2 over a 1. So that's going to be a fall of 2 for a run of a positive 1. And I get one of the questions I frequently get is how do you know that the run is this way? Well, this is a positive number. This is the positive, to the right is the positive direction in the x. This is the negative direction in the y, so it's a fall of 2. So yeah, when I do this, I'll graph my line, and sure enough, we're right here. So my solution here is going to be 1, negative 1. And just like that, we have graphed our lines, and we found that point of intersection, so we found our solution. All right, and I will catch you in the next video.